Dear students, welcome to my YouTube channel PCM Academy. Let us continue our discussion on problems and solutions from the book H.C.Verma. You know this is a very popular book, and we have started with the chapter of Newton's laws. This problems and solution series will not be very helpful for JEE main and advanced students, but also it will be very helpful for the aspirants of IIT JAM physics. Because if you see the IIT JAM paper, then there are a lot of questions that are asked from the syllabus of JEE Advanced. So you should practice these books. Okay, so you can take the help from this video to solve the problems. So let us continue from the question number 6, because up to question number 5 I have discussed already. Okay, so this is our question number 6. So the question is that a particle of mass 50 gram moves on a straight line. The variation of speed with time is shown in figure. Find the force acting on the particle at t is equal to 2, 4 and 6 seconds. So you have to see the figure. So if you see, this is the VT graph, and you know the slope of VT graph is nothing but the acceleration. So acceleration is nothing but, if you know from your kinematics, that acceleration is nothing but slope of VT graph. Slope of VT graph. Okay. Now if you see the graph, you can see for this portion, this is the horizontal to time axis. That means acceleration is 0 here for this. So for t is equal to 4 seconds, your acceleration is 0. That means force equal to 0. But if you see this portion, that is from 0 to this, so the slope of this graph, if you see, I think this will be 3 and this will be 5. So if you see along this time axis, this is 3 seconds, this is 3 seconds, and if you see the vertical axis velocity, this is 15. So you know, if this is theta, then the slope of this graph will be just tan theta. So A will be just tan theta. A will be just tan theta. So what will be your acceleration? That will be perpendicular divided by base. That means 15 by 3. That is actually tan theta. So that is 5 meter per second square. And if you see this portion, then this is just opposite to this. So the slope of this will be same, but the acceleration will be negative, because here for the time 5 seconds to 8 seconds, this is deceleration. Okay, so here A will be just minus 5 meter per second square, and here A will be plus 5 meter per second square. This is the basic difference. So we have 3 points, that is 2, 4 and 6. This is 2, this is 4 and this is 6. Okay, so for 2 seconds, what will be your force at t is equal to 2 seconds? Your force will be mass into acceleration, and mass is just 50 gram. So we have to convert this in kilogram. So 50 means, gram means 50 into 10 to the power minus 3 kilogram into acceleration, that is 5. So 250 into 10 to the power minus 3 Newton, that means 0.25 Newton. So 0.25 Newton is the force at time t is equal to 2 seconds, and will be same for time t is equal to 6 seconds, but in opposite direction. So at t is equal to 6 seconds, your force will be same, the magnitude of force will be same, but opposite direction, because the motion is in deaccelerated form, opposite direction. Okay, and at t is equal to 4 seconds, you see the acceleration is 0. So at t is equal to 4, force will also be 0. Okay, so this is how you can solve this problem. Now let me solve next question. This is question number 7. Okay, so the question is that two blocks A and B of mass MA and MB respectively are kept in contact on a frictionless travel. The experimenter pushes the block A from behind so that the blocks accelerate. Okay, if the block A exerts a force F on the block B, what is the force exerted by the experimenter on A? So first, let us draw the diagram. MA and MB are the two blocks. Suppose these are the two blocks. Suppose something like this. So this is block A, okay, of mass MA, and kept in contact. So another block, suppose this is block B, mass MB, and they are frictionless table. So this is just frictionless surface. The experimenter pushes the block A from the behind. Okay, so experimenter pushes the block A from the behind, so that the blocks accelerate. If the block A exert a force F on the block B, so F exert force on B. So here is the force. So the F force that actually exerted by A to B, this is F. Okay, and let us suppose that the force given by the experimenter, that is F dash. So we have to find F dash basically. We have to find basically F dash. Okay. So what will be the acceleration? If the force is F dash, you can see the acceleration is here, the net force is F dash, and here in this portion, this force will be action reaction force. So if A exert force B by an Fa by a force F, then B will also react with the same force in opposite direction. Okay, so if you draw the free body diagram of these two objects, then you can understand. For MA, if you see, the forces are F dash is given in this direction, and F will be in the opposite direction, that is in this direction, and acceleration will be along this direction. So acceleration will be same. But if we talk about mass B, then the only force that is exerted by A on B, that is along this direction force. So if you solve these two equations, you will get F dash actually. So A and F, you will get A as well as F dash. So if you use the Newton's equation, this will be summation Fx is equal to summation Fx, that is the force, net force along x-axis, is equal to mass into acceleration, that is ma into A, and that is basically F dash minus F. Summation Fx is equal, and that is ma into A. Okay, so you will get A from here. So just A will be what? F dash minus F divided by ma. Okay, and if you see this here, only force is F. So if you talk about summation Fx is equal to mb into A, then your just F is equal to mb into A. But what you need F dash. Okay, you need F dash. So just if you want, you can put this F here. So this, let us suppose that this is your equation 1 and this is your equation 2. So here F is given, you can see F is given, but what you need F dash. Okay, so if you want, you can substitute this value from equation 2 here. So from this equation, what you will get just F dash is equal to just F plus ma into A. Okay, so if you write mb here instead of F, so it will be just mb plus ma into A. Okay, so you will get A from here. Now let us substitute here. Okay, so from equation 1 we will get just F dash equal to just A plus ma into A. Okay, so A means what? We will get A from here. A will be just F dash divided by mb plus ma. Okay, so ma plus F dash divided by mb plus ma. Okay, so if you take common F dash, it will be just 1 minus ma divided by mb plus ma equal to F. So you can find from here just F dash. This. You have to set this equation, then you can solve easily. Okay, solution is the main thing here. because you have to express this f dash in terms of f and ma mb, because in the question you can see it is given just ma mb and f. Okay, so what will be f dash here? So f dash into just this is mb plus ma, and it will be just mb f. So f dash is equal to just f into mb plus ma divided by ma. This will be your answer to this problem. Okay, but if you want, you can solve this problem in another way also, because you don't need actually always two equations. You can solve it by using one equation. With acceleration, you can directly find out from here. That is, the acceleration is equal to net force divided by mass, something like this, ma plus mb. If you want to find out acceleration from this equation directly by this equation, then you can see this is same. So if you get this, and if you get this, then you can substitute a in these equations, then you will get directly. If you substitute a here, this a here, then you can find out f dash easily from these two equations. Okay, so but this is actually the method that I have discussed with you initially. So you always you need to draw the fluid diagram of each and every object, and then you have to set the equation of motion, and then you have to solve it. So this is actually the procedure. But if you want to save your time, then you can find out in this way also. So this is just a shortcut method, you can say. First you have to find out acceleration, then you have to substitute in this equation, so you will get easily. Or you can substitute this in these equations also, that you will get easily. So I can tell you this method very easily you can solve. Okay, just you can see. So these two blocks are here like this. If you want, you can solve in this way also. This is best method that you can use. Okay, so as the force is f dash, so what will be the acceleration? Acceleration will be just, you can find it in one line, that is acceleration is just net force divided by total mass, that is ma plus mb. So this is very easy. Now you don't need two equations, because one result you can already get, so you don't need two equations. So you can find out by drawing the free body diagram any of this ma or mb. So we have the free body diagram for ma, that is here the force f and f. You have this action reaction force for mass ma. In this direction there is f dash, and in this direction there is f. And for mb, this is your f only, and the acceleration is same. But you don't need two equation. If you don't want, you don't need to write this equation. You can write this equation from here. So this is summation fx is equal to ma, that is f is equal to mb into a. Now if you substitute this a here, what you will get? mb into f dash divided by ma plus mb. And from here you can find out f dash directly, that is ma plus mb divided by mb into f. So this will be your answer. So you can find this problem in this way also. Okay, let us solve next question, that is question number 8. What is saying here? A raindrop of radius 1 millimeter. So here the radius is 1 millimeter just, and 1 millimeter means 10 to the power minus 3 meter, you know. And 4 milligram, the mass is just 4 milligram, that means 4 into 10 to the power minus 3 gram, and that is 4 into 10 to the power minus 6 kilogram, with a speed of 330 meter per second. So the initial speed that it will hit the person, head of a bird person. So this is the head. So it will hit with a speed u is equal to 30 meter per second. The drops splash on the head and come to rest, assuming eventually that the drops cover a distance equal to the radius on the head. So it will cover this distance just. So you can see, you can write this as your distance travel. So the final velocity will obviously be 0. So you have to find out acceleration first, then you can find out the force exerted by each drop on the head. So what will be your acceleration? You can use the kinematics equation, that is v square is equal to just u square minus twice as. Okay, now at the final velocity is 0, so 0 is equal to u square minus twice as. So your acceleration will be u square upon twice as. So what will be the force, mass into acceleration? So the force will be ma, that will be m u square by 2s. So what is m here? M is 4 into 10 minus 6. What is u? U is 30. So 30 square divided by 2 into s, and s is just 10 to the power minus 3. So you can solve easily. So it is 2 will cancel, and 10 to the minus 3. So it will be 3 into 3 9, 9 into 2 18. So it will be 18 into 10 to the power minus 4 into 10 to the power 3. That means 1.8 Newton. Okay, so what 1.8 Newton force will be exerted by each drop on the head. Okay, so this is how you can solve this problem. So now question number 9. What is question number 9? A particle of mass 0.3 kg. So here the mass is given at 0.3 kg. It's subjected to a force F is equal to minus kx. You know, this is the form of spring force, and k is equal to 15 Newton per meter. So the force constant is given just 15 Newton per meter. What will be the initial acceleration if it released from a point x is equal to 20 centimeter? That means 0.2 meter. So x is equal to just, so when x is equal to 0.2 meter, so what will be the initial force? So initial force, the magnitude of force will be just k into, k means 15 into 0.2. So that is just 3 Newton just. So what will be the acceleration? Acceleration will be mod f divided by mass, that is 3 Newton divided by 0.3 kg. Okay, that means it will be 10 meter per second square. So this is how you can solve this concept. This is here initial acceleration. Here you can see what will be the initial acceleration. So that's why I can write x is equal to 20 centimeter. Because initially x, the compressed length is just 20 centimeter. Okay. Next, question number 10. The spring shown in figure are unstretched. Initially these springs are unstretched. A block is displaced by a distance x and released. So suppose this block is displaced in this direction by an amount x. So what will be the force? Force will be acting along this direction, that will be k1x. Similarly, if you move this block along this direction, so this string will be elongated along this direction. So the force will be acting along this direction, that will be k2x. Because you know always the restoring force will be developed in opposite direction along which the spring is elongated or compressed. So for the first spring, the compression is along leftward direction, the force will be along rightward direction. But for the second spring, you can see the force is along the left direction. So the extension will be in left direction. So the restoring force will be in right direction. So that means these two forces k1x and k2x that will be acting on m will be in the same direction. So the net force, you can say F, that is just k1x plus k2x. K2x, that means k1 plus k2 into x. Okay, but what will be the initial acceleration if you talk about? Then acceleration is just force divided by mass. That means k1 plus k2 divided by m into x. So this will be the answer to this problem. Okay, so thank you. In the next class, we'll see the next problems from the question number 11. Okay, thank you.